Okay, so the next topic I'd like to talk about at level 2 is working with ratios and proportions. This is quite a big set of topics, there's quite a lot to talk about, but hopefully it won't take another hour like the fractions video took. So let's first break down what a ratio actually is, because that's the first thing. Okay, so if we're looking at a ratio and comparing it, figuring out what it is compared to a fraction, let's see we've got these two circles here. I've split them both into two pieces each. So if I colour this one red and colour this one blue, just to show you, and then I colour this one blue and I colour this one red. Okay. As a fraction, what we'd say is, well, how many pieces are we talking about? Let's talk about the red pieces. So if we're talking about red for both, there are one red piece out of two pieces. So as a fraction, this is 1 out of 2, or a half. Half of the circle is red. That is as a fraction. And remember that a fraction is the amount of pieces that we have, the equal sized pieces on the top, or the numerator. That's how many pieces that we have. And on the bottom is how many pieces there are in total. Again, making sure that all the pieces are the same size. So we've got one piece out of two, 1/2. As a ratio, it's a similar sort of idea, but slightly different. We say, okay, well, if we're talking about red again, there is one red piece, and this will be blue because we've got to represent everything in a ratio. One piece is red and one piece is blue, so the ratio is 1 to 1. For every piece that's red, we have one that's blue. The difference between this ratio and this fraction is the total number of pieces is on the bottom of the fraction, but the total number of pieces is the combination of both of these numbers. 1 add 1 is 2, so we end up with 2 pieces. If our ratio was 1 to 3, for example, okay, we'd say, right, we've got one piece, let's say this is red, and this is blue. We have one piece that is red, and 3 pieces that are blue. Each piece is the same size, but there are 3 of the pieces here and only 1 here. So this would actually be, if I draw a little circle for you, if I did a visual representation of this, this would be a quarter, or how we represent quarters in a ratio. We'd say, okay, well, I've got one that's red, one sized piece that's red, and 3 sized pieces that are blue. And so this would be how we draw quarters. Again, the total is 4. So we know the total of the pieces is 4 pieces. And if we're talking about red, I've got 1 out of the 4 pieces that are red. So that's the difference between the fraction and the ratio. They mean the same thing. 1 to 3 is the same as a quarter. 1 to 1 is the same as a half. But you've got to be careful about how you represent them, how they look. Okay, so just as a brief, real quick practice, I've got 2 identical pentagons here. And what I want you to do is first write what you think this would be if we're talking about red again for both. What you think it would look like as a fraction and what you think it would look like as a ratio. Okay. Okay, so we've got our fraction. There are 2 red pieces out of how many pieces in total? 1, 2, 3, 4, 5. So we've got 2 out of 5 red pieces. That's what we're talking about for a fraction. As a ratio, we've got 2 red pieces and we have 3 blue pieces. So red to blue. And we always label our sections so we know what we're looking at. 2 red to 3 blue. So we know it's 2 to 3. That would be our ratio, 2 to 3. Okay. And so very good job if you manage to get 2 to 3 and 2 to 5 or 2 out of 5. Make sure that you know the difference between a fraction and a ratio. We are still talking about equal sized pieces, but the share of the pieces won't be the same. So, you know, I might have 2 here and 3 here. I could have 1 and 4, 5 and 7. Rather than this, where this doesn't mean 2/3. This is actually 2/5 of the whole thing, and this is 3/5 of the whole thing, because to get the denominator, you would add both of these together, and that would give you the start of your fraction. Okay. So we can also simplify ratios just the same. We're going to step away from fractions for a second, and this is the final time we're going to talk about them. As a fraction, if we're talking about the red again, I'd say there are 2 out of 6 pieces in total, because we have a hexagon here and it's split into 6. Separating this down and splitting it into pieces, we can half both of these numbers and we'd end up with 2/6 is the same as 1/3. Okay, that is our simplification of this fraction. As a ratio instead, again, if I do red to blue, making sure you label which one's which so you don't get them the wrong way around, I would say this is 2 and this is 4. We can simplify a ratio just the same. We pick a common factor, in this case 2 fits into both numbers, and we divide both the numbers by that number. So 2 divided by 2 is 1, and 4 divided by 2 is 2. So our simplified ratio is 1 to 2. So if you see it in the simplified form, or they ask you to put it in its simplest form, 2 to 4 simplifies to 1 to 2. So we've ended up with it in our simplest form. It's exactly the same. Again, you can sort of work it out from the fraction if you want. This is 6, so 2 add 4 makes 6. This is 3, 1 add 2 makes 3. So you can go from the fraction to a ratio if you want to. Just bear in mind that if we're talking about red, then what's left must be blue, because in this case it's only red and blue. So that is simplifying a ratio, just the same as simplifying a fraction. Common factor, divide both the numbers by that number. Remember that what you do on the top, you must do exactly the same on the bottom. So you have to divide by the same number or times by the same number. It has to be the same. Okay. So the kinds of ratio question you actually get in any level, but especially level 2, are sharing questions, usually to do with sharing money into a specific ratio. What's called a change one ratio, which we'll get onto a little bit later, and then a change total ratio, which is slightly different as well. These two, I'm going to star here, are similar in the sense that you do the same method for both, but how they look is a little bit different. Okay, let's start with sharing. Sharing questions are the absolute basic ratio questions that you're going to get given, and what you have to do is as follows. Let's say we've got a ratio of 1 to 3. Yeah, that means that we have one equal sized piece here and 3 equal sized pieces over here. And let's say we're going to share the amount of £20 into that ratio. Okay, what we do is we add up our pieces to work out how many we're actually talking about. So in this case, 1 add 3 makes 4. And so we know we're going to take this 20, which is the total, and split it into 4 pieces, like a fraction. So we're going to say, okay, well, 20 divided by 4, which I can write like this. How many 4s makes 20? Well, that's 5. So we know that one piece is worth 5. And I'm going to write that down. This is one part. We call it a part in a ratio. One part is worth 5. And we know that 1 is actually here. So if one part is worth 5, this 1 is actually worth 5. But what about the 3? Well, if one part's worth 5, then 3 parts must be worth 3 times as much as 5. 3 times 5 is 15. So we end up with 5 to 15. Our working out would be like this. You do 5 times by 1 is 5, and 5 times by 3 is 15. And so we end up with those two numbers there. To check our answer, we make sure that when we add them up again, we do get 20. 5 add 15 makes 20, which should be the case because that's what our total is supposed to be. And this is generally how these sharing questions work. Of course, in functional skills, you'll get a lot more words involved, which we're going to talk about in a minute. But this is the general principle for a sharing question. You add up the parts together, you divide the money by the amount of parts you've got to work out the size of one part, and then multiply that size back out into the ratio to get the correct figures, in this case 5 and 15. Okay, so here's another question. We're going to talk about this one as well, and then we've got one for you to do. So, Adam and Baz share £30 in the ratio of 2 to 1. Up to now, I've been making the smaller number on the left, but that doesn't have to be the case. The key thing to remember with any ratio question is that the way that you read it is the way that you write it. So it says Adam and Baz. Adam is 2, so I'll write Adam is 2, and Baz is 1. And that's why I label them, because that helps me keep track of which number is actually which. Okay, so whatever you read it is the order you write it. Adam, Baz, A, B. Okay, and we know that the total money they're talking about is £30. So that's going to be our total of money that we're talking about. And we're going to share it into this ratio. So again, first thing we do is we add up our two numbers. 2 add 1 makes 3. We do 30 over 3 to get what one piece is. In that case, it's 10, because 3 goes into 30 10 times. So one part is worth £10. Then we multiply that 10 back into the ratio. So for Adam, it's 10 times 2, which is equal to 20. And I'm going to write that's Adam. Okay. Then I'm going to do 10 times 1, which is just 10. And that's going to be for Baz. And so for my answers, that will be what I'm going to write. Adam is 20, Baz is 10. And you might get an answer box to put each one in. Make sure you put the right number in the right column. And the way to do that is just to make sure that when you read it, it says Adam and Baz. So it's Adam is 2, Baz is 1. Okay. And that's the general principle for how these are going to work. Okay. So here's an example question. I'm going to read the question out to you. And this is without a calculator, this one. And I'll give you a minute to pause the video, have a go, and I'll be back with you in a few seconds. So Gary and Johanna share £81 in the ratio of 4 to 5. Work out how much money Johanna gets. You must show you're working and show a check for your answer. Okay, so have a go, pause the video. I'll see you in a few seconds to talk about it. Okay, so we are told that they're sharing it in the ratio of 4 to 5, and it's Gary and Johanna. So I'm going to put G and then J. It could be Johanna, but I'm not sure, so I'm going to say Johanna. Share £81 in the ratio of 4 to 5. So 4 to 5, so Gary is 4 and Johanna is 5. Cool. Then we know that that is a total of 9, because 4 add 5 makes 9. And 81 is the total, so I'm going to do 81 divided by 9, which gives me that 9 is the size of one part. I'll just put 1 pt here. So the size of one part is 9. Finally, I'm going to do for Gary, which I'll just do G, is equal to 9 times by 4, because he's worth 4 parts, which makes 36. And Johanna is 9 times by 5, which is equal to 45. When you do this, make sure you add them back up together to make sure that you do get 81 at the end, which in this case I do. Always make sure you do that, because if you don't make 81, you've gone wrong somewhere, and that gives you a clue of where to start looking. So in this case, Gary gets £36 and Johanna gets £45. Make sure you put your units on if you're going to leave your answer like this. Put your units on so we know what we're talking about. Show a check for your answer. For these sorts of questions, we're going to say, okay, well, if 36 and 45 makes 81, then I'm going to do 81, take away 36 is equal to 45, and 45 divided by 5 gets me back to my 9, which is the size of one part. Or you could have said 81 take away 45 makes 36, and 36 divided by 4 gets me back to the 9, which is my one part again. You're going backwards to get back to the size of each person relative to the ratio. You know that it's 9 is one part for both of these. Both of these steps would be required for your reverse check. Okay, so you want to get back to a sensible answer. And this would also help you highlight that you've made a mistake. For any reverse check question, just as a general suggestion, always actually do the calculation. Don't just write what you think it should be, because that will tell the examiner that you didn't actually check it. Actually do the check, and if you get a wrong answer, that is still valid. You can say, I've checked my answer and I know I'm not correct because what I've just done doesn't get me back to where I expect to be. That is a valid check. That's the point of a check, that you're showing your answer, you show understanding that you know what you're supposed to have done and what you haven't done. Hopefully your check will get you back to the right figure, but if it doesn't, that is still valid as long as you explain, this shows that I can't be correct with my first answer because it doesn't make sense. That is perfectly valid as well. You'll still lose marks for not getting the correct answer, but at least you get some marks for showing understanding, which is just as important. Okay, so that is sharing in a nutshell. We can also talk about a 3-part ratio. Up to now, I've been doing A and B. Let's say A to B is 1 to 2, right? But there's nothing stopping us saying A to B to C is 1 to 2 to 3, for example, or 3 to 5 to 7, or something like that. The rules of a 3-part ratio are exactly the same as a 2-part ratio. So don't be scared if you see a question that has 3 bits, 4 bits. It's unlikely you get more than 3, but the rules are exactly the same. If we take, let's say, £60 here, instead of doing 1 add 2 makes 3, we're going to do 1 add 2 add 3 makes 6. So 6 is equal to 60. So divide that by 6. That means that 1 part is equal to 10. And that means that we can multiply those out. So 10 times 1, 10 times 2, and 10 times 3. Just with easy numbers to get you into the idea. That's 10. That'll be 20. And that'll be 30. And then to check it, we make sure that they do add up to 60 again, which they do. So that is the same principle. So for any of these questions we're going to talk about, whether we're sharing out money, whether we're changing a total, whether we're changing one element, it works exactly the same whether we have one bit of 2 ratios or 3. Only 2 elements or 3 elements. It's exactly the same. So don't worry about that too much. Here's an example of a 3-part question. Okay. Remember that it's exactly the same though. So I have some counters in a bag, either red, blue or yellow, in the ratio of 6 to 4 to 1. That means that it's red, blue, yellow, 6, 4, 1. So red, blue, yellow is 6, 4, 1. Remember that the order they tell you it is the order you write it down. That's really important. The red, blue, yellow, 6, 4, 1. That means I know the total straight away is 11. Okay. I have 77 counters in the bag. How many of each colour are there? Well, the total I'm talking about is 77. So I'm going to do 77 over 11, which means that there's 7, which is 1 part. Okay, so the size of 1 part is 7. Then to work out the red, the blue and the yellow, red is going to be equal to 7 times by 6, which we should recognise as 42. Blue is equal to 7 times by 4, which is 28. That's a 2. There we go, 28. And then yellow is equal to 7 times by 1, which is equal to 7. When we add all these up together, we'll get 77, which we should check. 7, that's 10, add 7 is 7, and then put the 1 down here. 4 add 2 is 6, add 1 is 7. So we end up with 77. So I'm happy that this is the right answer. It doesn't guarantee that you'll be correct, but you're certainly a lot happier than this. If this didn't add up, you'd know you're wrong. So red, there's 42, blue, there's 28, yellow, there's 7. That would be my answer for this question. But you see, it's exactly the same when we're sharing stuff out, whether there's only 2 or whether there's 3. Identical in terms of the method. Okay. So that is sharing stuff out. And remember, we'll be coming back to 3-part questions as we go along. This is what's called a change 1 question. So usually it's with you've got 1 or 2 or 3 different elements and one of them is going to change. So let's say we've got, I don't know, let's do red and blue paint because that's a classic one. And the ratio is 1 to 2. Okay, just to keep it nice and simple. We don't talk about a total. They say that they only have half of a tin of red paint. Okay, and I want to work out how many tins of blue paint I should use. It's important to note at this stage that you see with all of my measurements so far, I've not put any units on my ratio whatsoever. That's important because a ratio doesn't care about units. Whatever you say is what you get. So if I say this is tins, 1 tin to 2 tins, that's fine. If I say this is litres, 1 litre to 2 litres, that's fine. If I say in weight, 1 kilogram of paint to 2 kilograms, not that you would, but you could, that would be exactly the same. So it doesn't matter what unit you put in, as long as you remember the unit so that you get the same unit out again. I said tins. So I said, I've only got half a tin of red paint. That's fine. Let's assume these are tins, which we can do. So we have 1 tin to 2 tins. So how many tins are we going to need when we only have half a tin of red? With any change 1 question, we do not add up the total and say this is 3 and then work out what this is going to be, because that won't help me solve the problem. What we do is we say, okay, what's changed? Well, red has changed. It used to be 1 and now it's 0.5. And we say, well, how has it changed? Well, hopefully we can see that from 1 to 0.5 is a division of 2. It's half as big because 0.5 is half. What you do like this with a fraction, whatever happens on the left-hand side, the exact same thing happens on the right-hand side. So since we did 1 divided by 2 is 0.5, 2 divided by 2 will give me the answer that I'm looking for. 2 divided by 2 is 1. So I need 1 tin. So my answer is going to be 1 tin of blue. Would be my answer for this question. 1 tin of blue. Because we've halved it. Now, you could have gone bigger as well. They could have said, oh, okay, I actually only have, I have 1.5 tins of red. So how am I going to get blue? I say, okay, well, how do I get from 1 to 1.5? This time I've times by 1.5. 1 times 1.5 is 1.5. So I do the exact same thing over here. 2 times 1.5, well, double of 1.5 is 3. So I end up with 3 tins of blue paint in that scenario. Just remember that whatever you do on the left-hand side, you do the exact same thing on the right-hand side, and that keeps it in what's called proportion, which we'll talk about more later. But yes, this keeps the ratio the same, but the pieces have gotten slightly bigger. Okay, so here's an example of an actual question that might be asked. Okay, I need to mix red and blue paint in the ratio of 3:2 to get the shade of purple that I want. If I only have 750 milliliters of red paint, how much blue paint will I need to use? Okay, remember, it doesn't matter what unit you use in a ratio as long as you use the right one or you remember what it is. Obviously, if they say it's grams, then it's grams. But if I haven't told you, in this case I haven't told you, it could be whatever you want. So since they want milliliters, let's assume these are milliliters. The first thing I always do is I write down the ratio again, but in the way that they've told me it. So it's red to blue, because they've said red then blue, and it's 3:2. Okay, now we read the question and we think about what it is, what kind of question it is, because this is where people make mistakes. They either start adding them up and trying to divide it when they're not supposed to, or they misread it. So we read it and we say, okay, what's changed? What's changed? We don't have 3 red anymore. We have 750 red now. So instead of 3 red, I'm going to write 750 red underneath, because that's what's changed. We've changed one element and the red has changed. How has the red changed? Well, we can do it in 2 ways. Either 3 times by something is 750, or if we're not sure, we could do 750 divided by 3 to work out what that something is. And if you do that, 750 divided by 3, you'll get 250. So to get from 3 to 750, I've times by 250. 3 times 250 is 750. Whatever you do on the left-hand side, you do exactly the same thing on the right-hand side. 2 times by 250 is equal to what? Well, 250s is 500. So we're going to have 500 milliliters of blue paint. So my answer is 500. And make sure at this point you put your units on, because we're talking about milliliters. So it's milliliters. Okay, just as an example of the same question but worded in a different way. If they said they'd used 0.75 litres of red paint, okay, so 0.75 litres instead, I can start exactly the same. And I can say, okay, well, from 3 down to 0.75, I'm dividing by something. I'm not sure what I've divided by. So 0.75 divided by 3, or 3 divided by 0.75. 3 divided by 0.75 is 4. So we've divided this by 4. Okay? Whatever we do on the left, we do exactly the same thing over here. So 2 divided by 4 is equal to 0.5, which means I'd need 0.5 litres, which just so happens to be exactly the same as 500 milliliters. But both of these answers would be perfectly good. It's just the question that's changed. You can do exactly the same method either way. In this case, I've divided because the number went smaller. In this case, I timesed it because the number went bigger. Whatever you do on the left-hand side, the exact same thing has to happen on the right-hand side. But it doesn't matter what units you put in. You can choose whatever makes your life easy, unless they tell you specifically that it's 300 grams to 200 grams, then you can't just change it to kilograms, for example. Okay, cool. So here is an exam style question that was taken from an exam paper that I've sort of adjusted a little bit for an example of a change 1 question. Okay, so a sorbet is made from honey and strawberries in the ratio of 1 to 4. 380 grams of strawberries are used. How much sorbet is made in total? Okay, so be careful. We're looking for the total answer at the end. Have a think, pause the video. I'll come back in a few seconds and we'll talk about it together. Okay, so as always, the first thing I'm going to do is I'm going to rewrite my ratio out as they've told me it. So I'm going to capitalize it. You don't have to. Honey and strawberries. And they say it's honey is 1 and strawberries is 4. Okay. Then we identify, well, what bits changed? Is it a total we're sharing out? Is it something else? No, the strawberries have changed. It used to be 4 and now it's 380. So it's okay, that's 4, now it's 380. And I say, okay, how do I get from this to this? I know I'm going to be multiplying by something because the number's gotten bigger. To check it, we can use our calculator to check it for now. 380 divided by 4 is 95. So we've times this by 95. Okay, 4 times 95 is 380. We do exactly the same thing over this side. Hopefully without a calculator, we can see that 1 times by 95 is just 95. Okay, but the answer is not 95. It's how much sorbet is made, and we're making sorbet. So the sorbet must be the total. So in this case, we're going to take our total, we're going to add them together, and we're going to get our answer. In this case, it's 475. So our answer in the end is 475 what? Well, it's going to be grams. Why is it grams? Because grams is what the strawberries were told in. So this must be grams as well. So this is grams in total. We made 475 grams of sorbet. So really good job if you managed to get 475. If you didn't, don't worry. Just go back to the start of the change 1 example, because this is where people start to make mistakes. What you mustn't do is add them up and divide this by 5, because this isn't the total of the sorbet. This is only the strawberries. So you can't do it like that. Okay, great. Next, we have changing the total. This is a similar structure to sharing out money, but often this won't be about money. So if we go back to our paint, for example, let's say red and blue again, and we say, okay, we've got 1 to 3 this time. But the amount of purple paint I want to make is 12 litres. Okay, I know that if I mix red and blue paint together, I make purple paint, but I know that for a fact right now I don't make 12. What we do with a change total question is we say, okay, well, I don't know what total I have right now, but that's what I should probably be doing. Red and blue makes purple, and 1 and 3 makes 4. Okay, how do I get from 4 to 12? Well, I do 4 times by 3 makes 12, because what I want is 3 times bigger than what I've got. And then all I do is I multiply each element of my ratio by that multiplier, in this case by 3. So 1 times by 3 is 3, and 3 times by 3 is 9. And so for both of these, we've timesed it by 3 to get our answer. 1 times 3 is 3, 3 times 3 is 9. And so what we need is we'd write down that red is 3 litres and blue is 9 litres. And that would be my answer for this question. Okay, so it's very similar to a sharing question because you can answer it the same way. You can say, okay, well, 1 add 3 is 4. 12 over 4 makes 3. And so 3 times 1 and 3 times 3. It just doesn't look like the same because it's not to do with money. If you see money, you know straight away. But if you see something like this, you might not be so sure. Okay. Now remember that this is when it's going bigger. The total might get smaller. And so you might have to divide instead. Okay. But other than that, it is exactly the same. All right. So here's an example question. I make butter in the ratio of 1 part salt to 14 parts cream. Okay. I make 300 grams of butter. How much cream will I need to use? Okay, well, the first thing I'm going to do, as always, is write down the bits I've got. So I've got salt and I've got cream, and I've got 1 part salt to 14 parts cream. And I know that in butter terms, then, 1 add 14 makes 15. So if I just added 1 gram of salt to 14 grams of cream, I'd make 15 grams of butter. Okay. Now, in real life, it probably wouldn't work like that because the salt might dissolve, but that's fine. So how much cream will I need to use if I've got 300? Okay, well, 15 into 300. How many 15s makes 300? Well, 15 times by 20 makes 300. So I do exactly the same thing to both of my numbers over here. So this is times by 20. This is times by 20. Okay, and then 1 times 20 is 20. 14 times 20 is 280. The question says cream, so my answer is cream. So it's 280 grams of cream. How do I know it's grams? Because this is grams. So since the measurement is given in grams, my answer must be given in grams as well. Okay, so 280 grams. I might write cream if I need to. 280 grams of cream. Okay, that is my answer. That's how this is going to work. Remember, for this one, it's the relationship between the old total, what it used to be, and the total that we're looking for. In this case, 300. Okay, so here is an example question that came from an actual exam. This was from an Excel one that I've adapted a little bit. Milo runs a rugby club. He needs to order size 3, 4 and 5 rugby balls in the ratio of 1 to 3 to 5. Milo needs to order 270 rugby balls. How many of each size of rugby ball does he need to order? Okay, so have a think about this and we'll come to the conclusion of what we think. Okay, so in this case, I'm going to probably do it a little bit differently. I could write 3, 4, 5, and then underneath write 1, 3, 5. But that's a little bit confusing because these are already numbers. So what I'm going to do is I'm going to write S3, S4, and S5, just because I don't want to confuse myself with the numbers later on. And we know the ratio is 1 to 3 to 5. So that is my ratio, so now 1 to 3 to 5. Okay, the total of that is 9. And this is going to be the total of the balls, which I'll call B. The total I'm looking for is 270. How do I get from 9 to 270? Well, 9 times by 30 is 270. You could also do 270 divided by 9 to get 30. So each number here is going to have to be multiplied by 30. Okay, so each number multiplied by 30. 1 times 30 is 30. 3 times 30 is 90. And 5 times 30 is 150. And so that is my answer. If you had little labels to put it, you might put S3 equals 30. S4 equals 90. S5 equals 150. Just as an example. Okay, that would be your working out. And if you get given a big box to write stuff in, this counts as working out. If they can see that you've times it by 30 and you've drawn arrows and you've shown where these numbers have come from, absolutely, you can use this as you're working out. You don't have to laboriously write down every single calculation you've done. If it helps you to do it in a more visual way, you absolutely can do that because it counts as working out, as long as they can see where these numbers have come from. I've worked out that 9 to 270 is 30, so I've worked out that I'm timesing all these things by 30. That is my solution for this question. Very good job if you managed to get this correct. Hopefully you're starting to understand how these sorts of questions look and how they can be worded. Of course, in one video, I can't go through an exhaustive list of absolutely every single way these questions can be asked. But in general, this is the sort of ways in which they like to ask these questions. Okay. Finally, what I wanted to do was talk about a 3-part ratio exam style question where it's explicitly 3 different parts. And it's a little bit more complicated, okay? So this is just for you to push yourself and challenge yourself. We will talk about it, we will explain it, but let me read it. Caitlin is making biscuits. They use flour, butter and sugar in the ratio of 6 to 4 to 3. Not going to be overly sweet biscuits, but that's fine. Caitlin has 900 grams of flour and 625 grams of butter. Caitlin wants to make the maximum amount of biscuits that is possible. How much sugar will she need to buy? So with most functional skills questions, this is multifaceted. There's multiple things you've got to do. But have a think. We've been given some stuff and some elements have changed. Okay. How much sugar do you think we're going to need to buy? Have a think. Pause the video. Come back in a few seconds. I will explain it and all will be revealed. Okay, so this was on a calculator paper. If you could do it without a calculator, even better, but this is on a calculator paper, so you're allowed to use one. First thing I always do, just because if you do it all the time, it becomes a habit and it becomes straightforward. You don't even think about it, you just start doing it, is I write the ratio out again in bits. Flour, butter, sugar. Okay, and I know that this is 6 to 4 to 3. Okay. That is my commonly used thing right now. Now, I could write 900 here and 625 here, but I don't know that that's going to be in the same ratio because it doesn't tell me this is in the same ratio. So what I'm going to start with is say, okay, well, 6 to 900, because that's what I do know. Flour's changed from 6 to 900. On my calculator, I'm going to say, okay, well, 900 divided by 6 is 150. So this is 150 times bigger. Do the same to both of these. So 4 times 150 is 600. And 3 times 150 is 450. Okay. So far, if I'm going to use absolutely every single gram of flour I've got, I'd need 450 grams of sugar. Okay. But as we can see, this would only use 600 grams of butter. So in this case, we're actually limited by the flour we've got because we've used all the flour right now. So this is my answer. 450 grams of sugar is the answer, 450. I'm going to prove it to you by doing it a slightly different way. Okay, I know that my answer is going to be 450 grams of sugar. I say, okay, if instead of doing this, I said, right, let's use the butter instead. So I'm going to say, okay, F to B to S is 6 to 4 to 3. And so instead it's become 625 to something, which we don't know. I'm going to take my 625, divide it by 4. I get this nasty decimal here. Since I could only use 156.25 times as much, okay, fine. Let's multiply both the other numbers by that amount. This should be a 3. It's not very clear, 3. There we go. Let's do 156.25 times 3. So that'll be 468.75. You think, oh, okay, that looks like more, so maybe Joe's wrong. But if we do the same thing to the 6, because it has to stay in the same proportion, 6 times 156.25, we get 937.5, which clearly is too much because I've only got 900. So this 937.5 can't work because I haven't got enough flour. So if I have to keep it in proportion, which I do, to make this in the same ratio to make the biscuits taste the same as they're supposed to, I cannot use the 625 grams of butter. I can only use 600 of it because I've got to use everything in the same proportion. I've only got 900 grams of flour, which means that 450 grams of sugar is my answer. That is the answer we're looking for, okay? That is how you have to prove it as well. The flour is the limiting factor. The way that I can prove that if I need to do it is I can say, okay, well, 625 divided by 4 is 156.25. So I can say that divided by that equals 156.25. And 900 divided by 6 is 150. Since this is smaller, this is the limiting factor. This is what stops me from doing more. So the limit is the flour. And so I've got to use this 150 as my numbers rather than the 156.25. This means that the 150 becomes my multiplier. That's what I'm going to times it by. Okay, so that is how these sorts of questions are worded, how they look, how they work. Hopefully, if you're not sure, your tutor or myself, if you need it, can explain why this works like this. But yeah, in this case, I'm limited by the flour because I've only got 900 grams, which means I can only multiply everything by 150. I can't multiply everything by 156.25. Okay, and similar to ratios, although not quite in the same way, is the word proportion. For it to be proportional, it's a whole thing split into different sized pieces. So you might have something here and something here. They won't be the same, but they might go up or down by the same thing. The word direct in the case of proportion means that whatever you've got, 2 different things, 3 different things, whatever they are, they're both either going to go up or they're both going to come down by the same thing. So both elements will come up or down by the same amount. So if we've got the example of 1 to 2 as a ratio, if I was going to expand this, make it directly proportional, I might say 2 to 4. Both have doubled, and so they've kept in proportion by both doubling. I could times this by 2 again, 4 to 8. And I've doubled it again. It's still in proportion, okay? It's changed, but both numbers have changed by the same amount. Likewise, I could say, okay, this is 10 to 50, let's say. So that makes 5 to 25, which makes 1 to 5. This was divided by 2. This was divided by 2. Then this was divided by 5. And this was divided by 5. And this is still in proportion. It doesn't matter that these two numbers are different. as long as they're the same on both sides. What's important is that this left-hand side and this right-hand side are the same, that both things happen to the same way to both numbers. So both divided by 2, both divided by 5, that's fine. You could have divided both by 10 straight away and gotten straight to this, which is why it doesn't matter, because you've just divided by a different number and you've gotten straight to the end result. Okay, so that is called keeping things in proportion, the directly proportional, which is why you can see they're related to ratios, although they're not always quite the same thing. They might not be written in a ratio form. You could see it looking like this. You could have a graph where you've got some information, and as something increases over here, so it's going bigger, it's increasing this way as well. Okay, you could also have it the other way around. So you might have this graph that is flipped around. I don't know if I think I can if I group them. There we go. If I flip it around like this, you might have a graph that goes like that. So you might have, as the number goes less over here, it gets less over here. Both are either coming up or coming down at the same time. In terms of a real life scenario where that might be the case, you might have something like, visitors to a swimming pool, and as the temperature in degrees C goes up, the amount of visitors goes up as well, because as it gets hotter, the amount of people who want to go to the swimming pool to cool off gets more. And so both things are increasing at the same time. Okay. Now, this might not carry on forever. It might get so hot people don't want to go outside. But as a general rule, both things will increase in a similar fashion to keep in proportion. Okay. So that's what a direct proportion is. Let's give you an example of direct proportion in a question. Okay, so here's an example of a direct proportion question. I want to make some soup. The recipe says I need to use 2 litres of hot water for every 600 grams of carrots that I use. I only have 1.6 litres of water, so how many grams of carrots should I use? This should seem very familiar, because this is technically just a change one ratio question, but without any ratios seen in the question. So what I'm going to do is I'm going to make a ratio out of it. Again, for any ratio question, I'm going to write down what I know. And so in this case, it's hot water. So that's the first thing they've said. And then they've said carrots after. So hot water to carrots. So that's going to be 2 litres. And this time I'm going to put my units in because they're different units. So I've got to make sure I write them down. 2 litres to 600 grams. Okay. But I only actually have 1.6 litres of hot water. That's what's changed. And I've got to work out what goes there. Like a change one ratio, I've got to work out the proportion that this has changed. How much is it changed by? To do that, I'm going to work out how many it's actually been changed by. So 2 divided by 1.6 is 1.25. So this has been divided by 1.25. That's what we've got here. It's gone down, so I know it's a division. It's divided by 1.25. The same thing, because it's directly proportional, the exact same thing must happen over here. So this is going to be divided by 1.25 as well. 600 divided by 1.25 is 480. So my answer is 480, but 480 what? It's 480 grams. So my answer is 480 grams of carrots. That's my actual answer there. Okay. So the only difference between this and a regular ratio question is you won't see a ratio written anywhere. And most commonly, the units you're given are different for both the things. In this case, one's litres and one's grams. It makes no difference though. Whatever you get, because it's directly proportional, which means I know that if one thing comes down, the other one comes down. Then I do the same operation to both things, whether it's litres or grams or whatever. Okay. You could change this to millilitres if you want to. You could change this to kilograms if you want to. It would both be exactly the same thing. But since I want grams, I'm going to leave my weight in grams. Whatever I do to litres doesn't actually make any difference. But that's the general idea of how these sort of directly proportional questions will work. One thing comes down or goes up. The other one will come down or go up by exactly the same procedure. So in this case, divided by 1.25. So this one was divided by 1.25 as well. Okay. So here's an exam style question just to show you how little it actually matters about what they're saying, what grams they use, what measurements. Okay. So Habiba wants to make cupcakes. She uses the following recipe, and this is a recipe for 12. 2 cups of flour, 1 egg, 4 tablespoons of butter, 10.5 fluid ounces of milk, 3/4 cups of sugar, 3 apples and a pinch of cinnamon. She wants to make 30 cupcakes. How many tablespoons of butter will she need? Okay, so have a think about this, see what you think you might do, and then we'll talk about it in just a second. Okay, so once again, I'm going to make a ratio out of this, but the hard part here is working out what ratio I'm actually supposed to be using. What am I actually going to do? So I'm going to write it in a slightly different way, okay? What I'm going to do is I'm going to say, okay, well, for people, in this case, the amount of people I'm serving, which is 12, is equal to some amount of butter that I need. In this case, it's equal to 4 tablespoons of butter. You could write this with a ratio as well. It makes no difference how it looks, as long as you get the right answer. But I don't want to make 12 cupcakes. I want to make 30 cupcakes. Okay? And so I've got to work out the relationship between 30 and 12. I know I'm going to times by something because it's getting bigger. So 30 divided by 12 is 2.5. So I'm going to times this by 2.5. Do the exact same thing over here. 4 times 2.5. And 4 times 2.5 is 10. So we end up with 10 tablespoons, which I'm just going to write TBSP, of butter. 10 is the answer. Very good job if you managed to get 10 tablespoons of butter. The hardest part for this question is working out how to relate what we know. In this case, all we know is that we have a recipe for 12 and we want to make 30. So these are the two things we have to relate to each other somehow, because that's the only thing we know that's changed for certain. And we know it's gotten bigger, so we know we have to times by something. That's the general idea and the rules for this. Okay, so that is direct proportion. Both things will go up or both things will come down by the same multiplier. Okay, cool. The other one we've got to talk about is something called inverse proportion. Okay. Now, inverse proportion is the hardest one, but only because of the way that it looks. So for inverse proportion, what we've got is as one thing comes up, the other one comes down. Or as one thing comes down, the other one goes up. That's why it's called inverse, because the opposite to what you expect will happen. All right. So as ratios, if we're talking about something like this, let's say we've got 5 to 10. Okay. If I change this to be 1 down here, your brain might say, oh, this has got to be 2 because I'm dividing by 5. But it's inverse proportion. So actually, I'll do this one over here because the first one went down. The first one went down, so it's gone down by how much? Well, 5 divided by 5 is 1. We do the opposite over here. So instead of dividing by 5, what's the opposite of dividing by 5? Well, the opposite of divide 5 is times 5. So 10 times 5 makes 50. Okay, that is how we're going to do this, and that's how it's different. For every other one we do, the same thing happens on both sides. For inverse proportion, the opposite happens on both sides. And the only way to know it's an inverse proportion question is to think about the context of the question and see what makes sense. Do you think it should take longer or less time? Do you think it should be more or it should be less? Okay, I'll give you an example of this in a second. All right, so going the other way then, if we start with, let's say 2 and 4, and I make this go up to 4, this will come down to 2. What's happened? Well, this side we've times by 2, so on this side we've divided by 2. Okay, this one's doubled and this one's halved because it's the opposite. So an inverse proportion will always do the opposite on both sides. As a graph, this would be like this. You've got this and you've got a line that goes down like this. So as we're going, let's say, as we're going across, this could be temperature again. Okay, as the temperature increases, let's say the amount of heaters you buy or get sold go down. People aren't buying heaters or radiators when it's 25 degrees outside. They're more likely to buy it when it's close to freezing. So this is an inverse proportional question. Okay, as the temperature goes up, the sales go down. Okay, other way around, you could have as the amount of time you take goes down, the amount of speed you'd have to do goes up. Because if you're trying to cover the same distance in less time, you'd need to drive faster, as an example of an inverse proportion. So usually it's to do with speed, it's to do with time stuff, or it's to do with anything else that you think makes sense for one thing getting less, but the other one getting more, or the other way around. Okay, here's an example of an inverse proportion question. I'm driving to work, and usually it takes me an hour to get to work if I drive at 20 miles an hour. How fast would I need to drive to get to work in 48 minutes? This doesn't say the words inverse proportion or direct proportion, but I've got to know and think to myself about the context of the question. If I've got to get somewhere in less time, because an hour is 60 minutes, I'll put 60 minutes here, and I've got to get there in less time. To get there in less time, I must drive faster. So that means as time goes down, speed goes up. That means it's an inverse proportion question. Again, we're going to write it like a ratio. So I've got time on the left-hand side, and I've got speed on the right-hand side. Since I want to work out minutes, I'm going to use this 60 minutes that I've already worked out. 60 minutes at 20 miles an hour. Okay, and I want to work out how to get there in 48 minutes. So what I'm going to do is work out the relationship between 60 and 48. 60 divided by 48 is 1.25. So I've divided by 1.25 to get from 60 to 48. Do exactly the opposite on this side. So because it's divide over here, I'm going to times by 1.25 over here. 20 times by 1.25 is 25. So to get there in 48 minutes, I have to go at 25 miles an hour. That is my solution. That's my answer. The only clue here is that I think if I've got to get somewhere faster, I've got to go quicker. I've got to take less time by going more quickly. So less time, more speed. That's an inverse proportion question. And they'll often look like this, to do with time, to do with how long it takes for things to happen. That's generally how it works. There is another way of doing this, if you want another way. The second way of doing this, and this works for every single question just the same, if we do our time it took multiplied by the amount of speed we went, 60 times by 20 is 1,200. What this 1,200 actually means is how long it would take if either I went at 1 mile an hour or how fast I'd have to go to get there in 1 minute. Both things are the same. Once we've got 1,200 divided by what we're looking for, in this case, how long it would take to do 48, 1,200 divided by 48 tells me the answer is 25. And you can check. Yeah, and this will also work just exactly the same. So you multiply the two things you do know, an hour is 60 minutes times 20 gives you 1,200 or 1,200. Then you divide it by what you want to find, in this case 48, and you get 25. Both methods are equally good. I chose this one first because it's what we've been used to doing, but this one is easier for some people to get their head around. Both give you the correct answer. So it doesn't matter how you do it, as long as you find one that you like and do that one all the time. Okay, so here's an example of a question. Take some time to think about how you want to answer it. I will answer it in two different ways, and you can pick the one you like best, but they will both give you the same answer. Okay, so Andrew and his brother are setting up eco cabins. They're like just sort of houses that run off solar power and things like that. With the two of them, it takes 6 days to set up one cabin. A friend joins them and begins working at the same rate. That's important because it means that everyone's working at the same speed, so you don't have to factor that in. How long will it take for the three of them to set up one eco cabin? So instead of 2 people, it's 3 people. So if more people are working on something, should it take more time or less time to finish? Okay, have a think. Work out what you think the answer is, and I'll talk about it in just a second. Okay, so method number 1. I'm going to make the ratio out of it like I've been doing the whole time. So I know that when there were 2 people, let's put this as P, the amount of time it took, 2 people took 6 days. I'll just write there. 2 people took 6 days. A friend joins them, so a third person comes and they start working at the same speed. So in this case, it's going to be 3. From 2 to 3 is times 1.5. 2 times 1.5 is 3. So 6 divided by 1.5 is 4. 4 days. So what we've got is that 3 people only take 4 days to do the same work. So the answer is 4. That's the correct answer. And that's one way of doing it, okay? The other way is to say, okay, well, 2 times 6 is 12. And 12 divided by 3, which is how many people we're looking at now, is 4. And so both ways, you get the same answer of 4 days, okay? If you don't get an answer of 4 days, it's possible that you've tried to do a direct proportion method when you should have done an inverse proportion method, because as the amount of people goes up, the amount of time should come down rather than going up, okay? So both methods work just fine. They get you the right answer either way. Whatever you like better is what you should do. As with all things in maths, as long as you understand it and as long as you get the right answer when you do it, that's what you should do. Even if the way you do these are neither of the methods that I've explained, as long as you can get to the answer of 4 and the way that you do it, you could explain to someone else if they asked you, that's absolutely fine, okay? And so that's a general sort of overview of the sort of questions you could be asked to do with ratio and proportions at level 2. Thanks for watching.